hello everyone, welcome to YourPedia Education. So today here I am going to discuss with you one questions, these kind of question set basically you need to take as a reference and prepare for conventional exam. Why I have taken this question, and this question is from signal and system subject, there is a specific reason behind that. See, I keep on telling you people, when you have a very less time, then you need to choose the question in such a way that they cover the entire topic. This question is involving 5 to 7 concepts in a single question. So if you are solving this kind of question, then it's a kind of revision to those all concepts also. So if we see, consider the parallel combination of the LTI system. So this is a parallel combination of the two LTI system, and he is saying the impulse response are given. For individual LTI system, the impulse responses are given. And then he is saying if input x of t is unit step, then what is the energy of the y of t? You can see how many concepts are now utilized here. So let me first summarize. The very first is the how to reduce the combination of LTI system into a overall LTI system. And second thing is that how you will calculate the output signal for the given system set, right? And third one is how you calculate the energy of the y of t. So guys, when you are solving this question, there are many properties which will be used here. So for a moment, let us assume you don't know any property. So what I can assume, this is x of t. So it's going here. So also it will be x of t, and it will be also x of t. See, if you know the distributive property, then directly you can basically conclude and reduce this into a single LTI system. But for a moment, I am assuming that you are not aware of that property, but still how to use. So what will be output here? So guys, output here will be how much? X of t and convolution of what? H1t. You know the output of LTI system is input convolution with the impulse response, and similarly here you can write x of t and convolution with impulse response, that is h of 2t. So ultimately both the output, whatever is coming here and here, they are getting into adder. So y of t can be written as x of t convolution h1t plus it can be written as x of t convolution h2t. So guys, so now there are some properties of the convolution. With them you can minimize it as a x of t convolution of h1t, and you can write plus h2t. So this is the distributive property of the convolution I am using here, and this I can give a one simple impulse response h of t overall, and y of t can be written as y of t is equal to x of t convolution with h of t. So I guess the thing is very clear. So what I am going to discuss here, guys, I am going to discuss with you people, whenever you have a parallel combination of the system, that LTI system can be reduced into a single LTI system where the resultant impulse response will be addition of their individual impulse response as mentioned here. So I don't want to go for the distributed and all property. I want to solve my question. What my question is, see, before calculating the energy of yt, I must know what is y of t. And when he is asking you to calculate the energy, you must be knowing energy in time domain can be calculated as minus infinite to infinite mod of y of t square dt. So this is the energy formula. That's what I told you people. This question involves a lot of stuff, right? So let us now move forward. What my output will be? My output was y of t is equal to x of t convolution of h1t and plus I can say xt convolution of h2t. This was my basically the output, and it's given that x of t let me write what is basically convolution of H1T. What is H1T? H1T given here is this one, twice of del of T plus 2 and minus, let me go back, thrice of del of T plus 1. And similarly, if I go for the next plus x of t and convolution, what is h of 2? H of 2t impulse response is given as del of t minus 2. It's del of t minus 2. So guys, again one more property is used here, that is the convolution property of the impulse. And you know, whenever you convolve any signal with the impulse, the answer is that signal itself. Is it clear? And if you convolve any signal with the shifted impulse, the answer is the same signal with the same shift as there in the impulse. So I am using this property. So can I open it? Can I write it twice of x of t plus 2? I am providing the same shift to the signal, whatever shift is here, because this is a convolution property I have written here. Similarly, minus thrice of x of t plus 1 and similarly plus x of t minus 2. So guys, this is the output of the signal for any arbitrary input x of t. But since examiner is saying that my x of t is equal to u of t, so for that my output will be, can I say my output will be y of t will be equal to twice of u of t plus 2 minus thrice of u of t plus 1, and similarly let me go back, this was plus u of t minus 2. So basically this is the signal for unit step input. Now we need to calculate the energy of this signal. So before going ahead, I need to plot a graph here. I am taking this as a time axis. If this is a time axis and here I am plotting the y of t. So tell me how the graph will go on. Check it please. How the graph will go on. So can I say guys, this is a point where minus 2, this will start, and similarly this at, let us suppose here is the point minus 1 and this is my origin and this is the point somewhere here too. Is it clear? First I mark the instant. So here change of 2, what is happening here? Here is the change of 2 is happening. How the change of 2 will happen? Initially I will come from minus infinite with 0, so this will be 0, so here I will go to 2. So if we see here at minus 2 final minus initial, the change will be this factor. Similarly at 1, at minus 1 instant, at this instant change is minus 3, means we are carrying the same value, we are carrying the plus 2 value up to this point, but at minus 1 there is a change of minus 3, it means we need to go up to minus 1. So this is some value which I will say minus 1, so change will be minus 1, minus of minus 2, minus 3, and then again I need to carry the same value up to this point, and at 2 there is a change of 1. So change of 1 can be achieved when I go from minus 1 to 0. So I will go here and I will do this, and later what I will do, I will simply plot this as a, guys 0. So this is my y of t signal. So guys, this is a homework and assignment for you people. What you can do, you can take this as a one signal, you can take this as a second signal, you can take this as a third signal and draw them separately conventionally and add and subtract, you will end up getting the same signal. So I had made a shortcut formula. This is giving me the instant at minus 2, this is giving me the instant from minus 1, this is giving me instant from 2. So this factor is the change. From here the change will be 2, so I am coming from 0. Is it clear? So I need to rise by 2. Then here at minus 1 change will be minus 3. This is the change. This is the amount of change occurring. Is it clear? I was here at 2. I need to go minus 1. Final minus initial, minus 1, minus 2, minus 3. And here at 2 the change is 1. So how I will get the change 1? From minus 1 to 0. 0 of minus 1 I will get the change 1. So if you want to put it conventional way, you can do like this way. Now how to calculate energy? What I told you people, energy E of y is equal to integration minus infinite to infinite mod of yt square dt. Check it, this is the energy formula. So I can open this now, everything is there. So I can write energy of Y is equal to integration minus infinite to 2 or minus 2, this is 0 dt, and plus integration minus 2 to, it will be minus 1, that is 2 square, that will be dt because value is 2, and from plus integration minus 1 to I am getting plus 2, that will be minus 1 square dt, and plus I will say this onward from 2 to infinite it's 0 dt. So I guess the things are clear now. So I can solve it. So it will give me something related to integration minus 2 to 1, it will be 4 dt, and plus it will be integration minus 1 to 2, it will be dt. So I will end up getting, I guess this will be from minus 2 to minus 1. So I will end up getting 4 and plus 3. So this will be equal to 7 joule. So guys, answer for this is 7 joule. Please check once. Any doubt then tell me. So you can see how many concept used, energy concept used here, and then you can see, you know, this convolution property concept used here. Then you can see here, you know, property or LTI system convolution property use, distributed property use if you wish to use, and then the graphical knowledge also involved, how to draw the graph from the given equation. So these kind of the question you need to solve when you are practicing the question for the mains exam, because they involve a lot of concept together. So when you're doing these kind of questions, that is a kind of quick recap for all the concern or all the questions, right? So I hope the things are clear. So answer is 7 joule. Thank you.